Hey everybody, welcome back to some more live coding. Today we're going to pick up where we left off last night in doing the file forensics with Rust, and we did a lot of good work last night, and a lot of it was kind of learning the intricacies of Rust. But today we're going to review, so we did an example of how to get metadata from a file and to dump the hex values. So let's run those and just kind of make sure everything looks good still. So the first one was the get file metadata. So let's try cargo build. And then we want to go into target, and it's got a debug, and there it is. There's our application. It's called get file, or get file metadata. We can run it, we'll get the help information. It says we need to provide it a file. So why don't we provide it the file itself? Let's get the metadata about it. And here we go. The name, is it a block device? No. Is it a character device? No. Is it a FIFO? No. Is it a socket? No, it's none of those things. Is it a directory? No. Is it a file? Yes. The permissions, 775. Last modified, 324.301, which is UTC, which is a minute ago, which is accurate. Alright, so that one works, that one looks good still. What was the other one we did? We did dump hex. So let's do the same thing here. We'll cargo build it. Go into the target, debug, and run it. Dump hex. Okay, it gives us the usage information. We need to give it a file. Same thing. Let's dump it. Oh, look how long that one's long. That's megabytes and megabytes of data. I suppose we could. Why don't we do that through less? Then we can actually kind of look through it. So cool. We've got our file dumped, and you can see there's some kind of signature at the top and some empty values. A lot of empty values here. A lot of empty space. That's most likely, some of it's probably stack space, but that's fine. So now we're going to work on some new examples and start knocking out the rest of the ones on this list. So we did those. We're going to use those as a starting place to do the next ones. And so one common task is, if you have a file, you have a binary file, let's say it's an executable, and you don't know what it does. One of the quickest and easiest things you can do to start looking through it is just start looking for ASCII strings inside of the binary. And a lot of times you'll find text that gives you clues about it. So what we're going to do is write an example that will go through a file, and if it finds characters that fall in the ASCII range, it's going to print them out. Otherwise it's going to skip the character. That way we can quickly find all of the strings in there together without having to dig through ourselves. So, okay, we're going to go back into our Rust directory, and we're going to say cargo new, and we'll say find ASCII in file. It's kind of a long name, I know, but it's going to be easier in the future when I need to come back and find my examples. So there it is, find ASCII in file. And now we've got a nice empty file. What I'd like to do, yeah, so now we have this other file as an example. Okay, so let's make this bigger. We're going to work out of these two files. So, let's see, what do we want to do? Let's start with the main. Well, I guess first we want to check the arguments, check the command line arguments, and we're going to need a file, right? Get a file from CLIR1, and then we're going to need to open it, iterate through looking for ASCII bytes. Okay, so why don't we do the same thing we've been doing in the other one? We'll create a function called check arguments, and since we're going to be doing the same thing and just capturing a file name, we expect one argument, and it's to be a file name. So why don't we go ahead and copy our check arguments. And if you missed it, we wrote this one last night, and all it does is it pulls the arguments from the environment using env args collect, and then we get a vector of strings, which is the arguments, and then we take the file name, or we create a new variable named file name, and we are getting the first argument, or not the first one, but the one in index 1, which is actually the second argument, which is supposed to be the file name. But if it doesn't exist, and they didn't provide it, then we say, hey, there's no file names provided, we print out the usage, and then we exit with an error code, anything non-zero, in this case a 1. And if we did get it, we just return the file name as just the string of the file name that was pulled. So then what we can do here is say let file name equal check arguments, and that will print out the usage. It calls print usage, but that doesn't exist yet, so let's also go ahead and copy over the print usage function as a starting place. And the nice thing is, because we are passing it the executable file name, which is argument 0, then we don't have to rewrite any code here. It's actually going to dynamically use whatever compiled file name it is. So if you ever rename it, it doesn't matter. It'll always use the file name, which is nice, which is what we want. And then we've got our main function, which is, so we do want to open the file, right? And we're going to read it. So once we have a file name, we're going to open it and then read it. And so in this case, let's say open file name. Let open file equals open file. And then, so what do we have here? What we get back is, oh, hold on, I need to attach it to the current cargo project. So we need to find ASCII and file and attach it to the cargo toml, which is like the package metadata file, so that it knows we're working on this specific application. And now it can tell me, oh, hey, wait, you're missing these imports. So I'm going to do Alt-Enter and just hit import, and it's automatically going to pull in use standard end at the top. Same thing with this red one, Alt-Enter, import, and because there's only one match that it found, it automatically did use standard file system. Okay, so now we've got, and here we've got the help information. Now you can see it says this is a result. And a result, we have to see if it's an error or if it is good. So what we're going to do is say if openFile.isError, then we're going to print a line that says no good, error, opening file, and then we'll print out the file name. So then we'll say file name. Sorry, couldn't open the file, and then we'll do a system exit. So just like we did system process exit, standard process exit with a code of 1, which just means an error, anything non-zero. Okay, so if there's an error, go ahead and bail, otherwise we can keep going and assume the file is good. So then we'll have openFile.unwrap to actually get the value itself. So I guess to be more accurate, we could say this is like the open file result. And because we're still getting used to Rust, I'm going to go ahead and be a little more explicit and name it that way. And then we have the actual open file. The actual open file is going to be the unwrapped value. So yeah, now we actually have the file object itself, and that's what the gray text is saying. So when we have the open file, we should be able to, yeah, read, and then we're going to have to pass it the buffer that we want it to read. And we can just have it read 1 byte at a time. I don't think that's the most efficient way to go through a file. So we'll do it in larger chunks, I think. And which file is it? It's the dump hex one. In the dump hex file, we have a nice example of reading. Here we go. And in this case, we're saying we made a loop that just says, while there's data to keep reading, we'll go ahead and keep reading. So I also want to copy over the creation of this buffer. Here we go. So we'll create the buffer here. Oh, and we need to be clear that it's supposed to see, it knows that it's a U8 here, or an unsigned 8-bit, a byte, basically, a char, but how come it's not inferring that? Is it because I'm not using it yet? Hold on. Interesting. I wonder if I just run it, or if I just build it, what it's gonna say. Unused, that's okay. Not in scope. Okay, let me make these two. Actually, I don't need to store the column. Let me cut out some of this stuff. Actually, let me comment out pretty much everything except the read logic itself. So we'll say let keep running equals true, and then we're going to say, yeah. So what happens is we're going to say keep running, and we have an infinite loop basically, and we're going to say, okay, read from the file, and say if you actually got data, if there was no error, rather, then go ahead and keep going. Otherwise there was an error, then keep running use false. Oh yeah, we're going to have to say mutable, let mute. There we go. Then here we go. So if the read went okay and there was no error, keep going. But then when we unwrap it, we actually see how many bytes were read. So if there were 0 bytes read, that means it's pretty much done. There's nothing left to read. So then we say, so I guess at this point too is where we would say break. Or continue. Actually, break might work. Break might work instead of having to call to keep running. So can we break directly? We're gonna have to find out. Can we break directly instead of using the bool var? Okay, either way, that's fine. It will keep working without it. Otherwise, we do have data. Oh yeah, and the data is going to be in the buffer. So what we'll do is say for here, I'm going to have to store this. So let's say let num bytes read equals data.unwrap. And then we'll say if num bytes read equals 0, then that, and then we can reuse this here, and then we can say for I and 0 up to number of bytes read, then do this. And in this case, we're just going to say, how about print? Just print it. Print it in debug mode. Don't care. Buffer character I. Actually, don't want print line either. I just want print. Okay, so let's try and run it. This should just print every character as it is, and then we're going to add in a conditional that says only printed if it's an ASCII one, actually. Cargo build. Check out everything we did wrong. Unused import. Okay. What else? Oh, yeah, weird comment. Didn't like my weird comment. For whatever reason. Document. Oh, okay, so three slashes is a doc string, a document comment. Okay, expected value. Found. Okay, line 46. What about line 46? Doesn't it like? Let's see. Well, let me just try building it now that I fixed the other things. Yeah, expected value found macro. Oh, I think I was supposed to do... No? That's how I did it here. File that read. let mutable file equals open file.unwrap. Oh, I think I have to do let mutable file. Oh, it's because it's actually called open file. And then I need to read back. Okay. I was referencing the wrong thing. Okay, so now I need line 31. I need to fix an ownership problem. So I can't pass the file name because it's owned. And so what I'm just going to do is say clone and pass it a copy of the string, which is totally fine. Pass by value. Okay, so now it built. Now that's good. So now let's try cargo run. It says our usage. Why don't we try and print out about the TOML file? Okay, cool. So it's printing everything we expect it to. Now let's go back and modify this. So instead of just printing everything, we want to say, what if I do it like that? Will it print it out as a character? No, hold on. Let's look up the format characters. Rust format characters. Here we go. I want, it says if you do nothing display, I want the byte as ASCII. Let's see. I don't want it to print out the numbers. Let's see. So what if we actually put a space just to kind of double check? Yeah, so it's the bytes, 91, 112. It's between 0 and 255. But let's see. Rust print ASCII char for bytes. Oh, do I need to convert it? I need to convert it to a character type. So maybe I can do dot two. There we go. 2 ASCII lowercase, 2 ASCII uppercase. Well, can I just do 2 ASCII? Can I just do to whatever ASCII it already is? I don't want you to change it. I want you to use... Wait, no, that didn't do anything. Let's try printing it like that. Okay, well that doesn't seem to actually do it. Let's see, hold on. Rust convert byte to char. Here we go. Using ASCII coding. 65U8 as char. As char. Oh. So instead of that, I say as char, like that. I'm basically casting it to a character. What am I doing? I need to try it down here. Yeah, there we go. Okay, so you basically cast it using as. I mean, normally I guess you would do it like that. Can you do that in Rust? Can you say print, okay, cast it to a character? No, it didn't like that at all. Not a function. Yeah, got it. Okay, so I guess that's how you cast things, as char, as character. Okay, so now I don't want to print that anymore. There we go. So now we're just printing out the file as it is, but let's see. What if we picked a binary file, like target, debug, find ASCII file? So now you can see there's all kinds of junk. There's blank ones, there's messed up characters, but there are some strings in there. So what we want to do is say, instead of printing everything, we actually want to say if the buffer, the character, which is element in buffer index I, is greater than, what is it? I'll have to check. ASCII character codes. 65 is capital A, I think. So we want everything from, we're going to use the decimal values, so we're going to say everything from 32, which is space, everything from 32 all the way up to 126. We'll say greater than or equal to 32, or buffer element I is less than or equal to 126. Then we will print it out. But what's going to happen here is it's going to print everything all bunched together. And you know what? This, let's see, are the spaces a big problem? No, that's, yeah, so sometimes the spaces do. Let's see, should we cut out the spaces too? We could make it an option. We could say to do add a flag to skip spaces, then ignore ASCII 32. Okay, we're just going to go ahead and ignore it. So if we rebuild it, we shouldn't get so many spaces now. Yeah. Now we see all... Where does it start? We shouldn't see any spaces. I guess some of those spaces are actually other characters. Or I guess maybe they're new lines or characters that you can't see? Wait, 32 was space, right? Yeah, 32 was space. Is that right? Hold on a second. I used to have a big ASCII poster that hung on my wall back in the days of QBasic. Yeah, so ASCII 32. Now hang on a second, something... Dark Coder says, hey Dark Coder. Welcome back. Yeah, so decimal 32. 32 space, so we want to ignore 32. So let's say cargo build, just make sure it still builds and everything looks good. Okay, so let's try it out now. We built it, cargo build, so we should be able to go into target, debug, and now we have this file. So I'm going to move this file into my home bin folder. So now, yeah, I should be able to run it from anywhere. Yeah, so I can run it from anywhere now. So I'm going to go check out, like, okay, how about, we gotta find some binary files, right? Well, the bin folder's gonna be full of binaries. So we'll try find ASCII and file. I guess some of them, let's find out, some of them are just, yeah, so those are just scripts. Most of them are, actually. Aha, that one's a binary. And actually, it's a really big file, so it's actually, like, it's still going through the file. It's taking a while to go through the whole file and parse it. How big was that one? 5 megabytes? So it took a few seconds. Let me try running it in the terminal as opposed to inside JetBrains. So it's called find ASCII and file, and that was a 5 megabyte file. Which one was it? Go packages. I'm going to do a time on it. I want to see how long it takes. And instead of printing it out to the console too, I'm going to dump it out to a file. So we're going to call it ASCII Dump.txt. and just see how long it takes. Okay, when you're not printing it out to the console, it only takes, you know, 1 second. So why don't we try opening that file with Visual Studio Code and check out the file that it created, because it is either binary or uses an unsupported text coding. So why? Hold on a second. Maybe I'm checking this wrong. Oh yeah, I don't want. Hold on, my logic here. I think my logic's wrong. If it's greater than 32 and less than 126, that was my big problem. So let's go back into our project, rebuild it real quick. Cargo build. I'm gonna go ahead and do the target debug. I'm gonna copy it there again. So now let's go back here. We'll run the same file. 1000. Yeah, about 1 second. Now let's try and open it up in Visual Studio Code again. Yeah, there we go. So now it's one big long. Let's do Alt-Z to turn on word wrap. And now there's definitely no spaces. It's all mushed together. So let's see. I want to at least separate groups. So I want to know if where the groups are. So let's at least put a space there. So we'll add our own artificial spaces anytime they are not consecutive. So we're gonna have to say let mutable consecutive ASCII is false. Or let's see, how are we gonna do that? We're gonna say last char was ASCII is false. And then let's see. So before we print it, we want to say if last char was ASCII, then we want to print it like normal. But if the last char was not ASCII, then we want to actually print out an extra character. Do that, and then we'll say last char was ASCII equals true. So now what's going to happen is, if the characters are consecutive, it will print them out, and as soon as there's anything non-ASCII, it will at least add one space between them. So let's try this again. Let's say cargo run, and then we'll run it on the what is it? Bin go packages. And then we'll dump it out into a file called ASCII Dump. And then we'll open it in code. What did it say? Could not find cargo toml. Oh, I'm in the wrong directory. There we go. Okay, so now we've got it. Now this looks a lot better. Now we can see at least where there are some breaks. And at the very beginning, boom, now we can clearly see ELF. And that's going to be a binary type. So right there, it paid off, and now we can see here, like, okay, these are separate. These are just kind of some random things separated. There's a group here, there's a group here. So now if we were looking for like a key, like a secret key or something, now we have at least a better chance of going, well, at least these are consecutive. If we know maybe the key is 8 characters long, then we could do something like, I expect it to be a digit. I guess, can you do regexes? Yeah, turn on regex and do digit. Times 8? How do you do, 2? I forget. I'm not gonna mess with the regular suggestions, but you could know what I mean. You could go look around and be like, hey, I need a 4-character string. That's what I'm looking for. As we go through, we can see a lot of these $H's. That's probably just some binary representation for something. So you can see clearly a whole section full of those H dollar signs. That's probably all the variable declarations and stuff like that. And as we go on, we clearly see another section, and that looks like It might even be some debug information where it's pointing out function names. Oh, look at that. Now we've got a whole bunch of strings that are probably used in this application, so that'll help us tell what this application actually does. Awesome, now you can see runtime stuff and more strings, and as you look through, you can find more clues. But I think what we've got right now, I think we can call this done. I think this is helpful enough. Those spaces, definitely critical to breaking this apart. Now you can really clearly see what the words are. Awesome. So I'm happy with that for now. So let's go ahead and clean this up. Is there any refactoring we want to do? Oh, actually what I want to try out is if I get rid of this whole idea of keep running, can I just say break when I need to? Just break. Then I'll just break out of, I'll just break out of the loop when I need to. So let me try, let me try this again where I'm just, okay, these are warnings. I guess I don't even need that variable at all anymore. I can get rid of you. Now let's see. Did it work? I'll try and open it up then. Yeah, I mean, it looked like it still worked okay. And did we have any errors? So let's try running it. And then I'll echo, were there any errors or did it exit clean? It exited cleanly with a 0, so that's good. Okay. Then the break is good, and then we don't have to mess with this logic of setting a keep running variable. So we'll just call break, and that'll break us out. I guess we could... No, I don't want to... Yeah, we'll just say break. Okay, so now I'm just cleaning this up. Let me... I'll put the buffer up there too. And I guess we can make the buffer bigger. What I wanted to do is reduce the number of reads that we did on the file, on the disk. So... yeah, it's a warning about the infinite loop, but that's okay. It's just a warning, and... so it still ran okay. Okay, I'm happy with this the way it is. I'm going to go ahead and add it and do a commit. Add, commit adding, find ASCII in file application. Push. So, Costub asks, why using Rust? Why use Rust? Well, there's a couple reasons, but primarily because there's been a lot of interest around Rust lately. Particularly in the security community, people have been pretty interested in it. And I'm interested in it because, for one, it's supposed to be very, very safe memory-wise. And I'm seeing that it is. They have very, very strict rules on ownership and access of variables. And because you get low-level memory access, then because of that, I think it also lends itself well to reverse engineering. So I'm just exploring it for the uses in security. And so it's partially a learning experience and to see if it's useful in this area. Okay, so that one is done. We can say that one's done. We'll move it up here. So what's up next? Looking for file signatures? Well, that's really just going to be a slight modification of what we have in this other project. So in this one, we'll say cargo new, find file signatures. That's going to be the name of our application. Find file signatures, and we'll open it up. And why don't we just go ahead and copy over... Oh wait, that's not the right one. I don't want to copy that one over. I want to copy over the last one we did, which was find ASCII. Okay, then we need to attach the right cargo toml file. And so what we're going to change here is basically say what file signatures are we looking for? So why don't we just start with maybe some basic maybe some image file signatures. So how about PNG? So this, they're saying this is the signature for a PNG. How about a JPEG? Okay, we'll go with that for now. Okay. Now, instead of looping through the whole file, we might want to do something a little different. So I'm going to comment that whole part out, but we still want to start with basically getting a file from the command line and then working with a file. Let's see. Pandal says, I think Rust have its conventions to call infinite loop just loop. Oh, interesting. Are you saying that there's no true, you just say while? Wait, now it's saying it expected something, it expects an up. Yeah, that's just, I think that's just a linter thing. Okay, so this is the signature I want to look for right now. Now what should we do? Should we convert the hex to decimal and then compare each byte? Or should we compare... Should we take the bytes, convert them to hex, and then compare them to this signature? Costab says, file input through stream is better, or direct low-level file read. So I am reading it in chunks. I am manually reading it in chunks. That's what you mean by a direct low-level read. I'm reading it in the chunks of the size of the buffer, and I chose the buffer of size 1024, at least for the last one. So in this one, like, let's see, we're gonna want to check for at least more than one signature. So yeah, why don't we try the PNG and the JPEG ones? Okay, so now we've got at least a few. And this one's gonna be JPEG. We need a label for them. And I'd like to be able to make it at least kind of user-friendly to create it, or create them, right? So it'd be cool if we could just say, like, put the string in there just like that. So what I think we'll do is convert the file pieces to hex and then compare them. I'm not sure if that's the best way to do it or not, but I think that's what we're going to do. And it also matters where the signature is. So for example, if the signature has to be at the beginning, then you want to make sure like this only happens in the beginning. But some of them are at the end, actually. I think zip files have their signatures at the end, if I'm not mistaken. But we're going to do sort of a naive check, and we're just going to say, hey, if these exist anywhere in the file in that order, we're going to say we go ahead and found it. It's not going to be very good because short ones like this might show up, but we'll see. I'm still not convinced this is going to be the cleanest way to do it, but I'm going to go forward with it anyway. So, oh wait, this one was actually PNG, not JPEG. So, I guess I'm going to start pseudocoding out my idea here. So we're basically going to, for each signature, there should be a seek too. Let me kind of make sure. Well, there should be a seek, so let's try this. For each signature, seek to position 0, and then read length of signature bytes. Should we go through the whole thing each time, or should we just look in the beginning? Let's go with a very naive one. We're going to say just look for these at the beginning. So right now it's only going to support signatures that are at the beginning, and then later we can expand it to add on to search everywhere, and maybe even be more intelligent and say, hey, you can add here, like in this case, you could make some kind of struct that says expects this to be at offset 0, or like from the end. I don't know, maybe we'll have to make more of like a plugin system where you have to create kind of an interface for each type of one. That way you say, okay, for each one, run through the function that checks for each signature. That way for each one, you can have a custom function and say, this one should just read the first 8 bytes of the file and compare them. Done. Next. This one, check the last 8 bytes and compare them. Or this one, you know, do this or that or whatever. So we're going to start off with the very simplest case, which is just finding them at the beginning. Kostov says, NIM programming language is good try. It's a mix of Python, Pascal, and C++. Now, I don't know if you were the one who recommended it the other day, but somebody did bring up NIM. And I did look into it. And it does look interesting. I can see how it's got like the Pythonic style syntax, Pascal where you define all your variables up at the top in one big block, and I guess, yeah, it's supposed to be like typed and compiled and everything, so, but it's interesting that it compiles to C. I found that pretty interesting. No, I haven't checked it out yet, but maybe soon. Yeah, so we'll start with 1, I guess. Read signature, and then see compare bytes read to signature. Okay, so that's what we're gonna do, or try to do at least. Okay, so we're gonna say open the file. We're gonna open the file. Oh, we already did the opening and the unwrapping, so we're gonna pull the data. And maybe we can specify the size of the buffer. Let me try something. Let PNG signature equal this. And that's a string, yeah, so what I want to do here is say length of string divided by 2. Because there's two characters for each byte that will end up being read. So if we just create a buffer that is exactly the size of this each time, then it will read exactly that. I wonder if we could just tell it how to read. We could say read 8 bytes. Yeah, I guess the second one would be... No, let's just leave it like that. So then let's just try to print the data. Okay, let's just see if our program even works. So this one's find file signatures. We're gonna say cargo build. Okay. Doesn't have a size at compile time. Yeah, okay. Okay, so we can't do that. I didn't think so, but I was curious. So we'll create a buffer at 1024 that should be big enough for anything that we need. But what I think we should be able to do here is say read dot length divided by 2. Maybe then we can tell it just to read that many bytes. Expected 1 parameter. Shoot. How do we tell it Rust file read n bytes? I want to read specifically. Read exact. There we go. I want to read exactly PNG signature length divided by 2. Expected 1 parameter. Which parameter did you expect? The buffer. Read the exact number of bytes required to fill buffer. Shoot, that's not what I want. Read the string. Shoot, can I just not tell it, hey, I want to read 7 bytes? Even though I have a buffer bigger than that? Well... I guess we can just read... it, and then we'll just check the first ones. But yeah, I guess Costup's point here is that if you read... Well, I'm only reading 1024, so I'm not reading the whole file. I'm totally okay with just taking a chunk of 1024 characters. So then why don't we say if... No, I think what I'm going to do is convert these... I'm going to convert these to decimals, and I'm just going to make it an array of bytes. So let's bust out the old calculator. And we're in programming mode, which is what we need. But we want to go into hexadecimal. And... so yeah, FF is going to be 255. D8 is going to be 216. FF is going to be another 255, and then DB, I guess it's only going to be three higher than that, so it should be 219. DB 219, cool. And we're going to say let PNG signature equal that. Excellent. And then what I will do is just leave that as a comment so we know what it is. Okay, so now we don't have to do any funky conversions, and then we can just say, how about this? We'll just go through we'll go through the length. We'll say 4. Do we have to say let I equals 0? Let I equals, do we have to do it in parentheses? We'll find out. I is less than PNG signature dot length I plus plus. Hold on, what's wrong? Oh wait, I forgot they have like their own for loop syntax. It's I forget. For I in 0 to the signature length. There we go. I think that's what I need. So now that's just going through the index, and we'll say if buffer of index I does not equal our signature at index I, then we're going to say match equals false. And we'll go ahead and assume that match equals true. Identifier expected got match. Hold on. Why is it? Hold on. Oh, match is a keyword, isn't it? Yeah, I think that was the problem. Match is a keyword. Okay, so now we'll just go and we'll check the signature and see if it matches. What does it say? Unused? Unused assignment. Oh, because we're not doing anything with it. So if signature matches, then we'll go ahead and print a line and say signature found. That's going to be a hit. So, and then which how are we going to label which signature it was? I guess we could have like a change it to a hash map to do convert to dictionary, or a hash map with named indices. Then we can say like signatures PNG equals this. Like signatures, let's see, how do you create hash map in Rust? Hashmap new. The type inference lets us omit explicit types. Okay, so what we want to do is say signatures is new hashmap. Okay, we're gonna have to do an import, alt enter, import. Let's import it directly by name. Okay. And what we have to do here was call insert. Oh, we need a comma here. There we go. Awesome. So now we can start adding them like that. And then we can actually have some keys with some indices. So now we can actually say like, hey, it actually found a PNG. Instead of just saying, hey, we found signature FFD8. but okay, we're gonna have to change the code a little bit to accommodate this. So instead of just saying in PNG signatures, we're gonna have to say signatures dot, how do you get an element? Now let's see, you've got get, iter. Yeah, I want to kind of iterate through each one. There we go. For key value in map.iter. Boom, that's what I wanted. So we're going to replace this for with that one. So basically we're going to say this is going to be the signature name. Or I guess we could say it's the file type. And the value is going to be the signature bytes. And the map is actually going to be the signatures. So we're going to iterate through the signatures, and then we'll say, in this case, it's going to be the signature bytes. Does not equal... Oh, wait a second. No, we do want the buffer, and then we want to check here the signature bytes. And then if the signature matches, then we can actually print out... Oh, you know, how are we going to do that? Should we create a new... No, well... Hold on, so we're going to loop through this first. I want to print out whether it matched or not, but I want to do it for each one. Okay, so we're going to have to do another loop inside here. So this is where we're going to get the file type and the signature bytes, and then we're actually going to have to loop through the bytes themselves, though. So that's going to look more like for I in 0 through signature bytes length. Then go, or yeah, that's right. And then outside of that is where we're going to put this. And then we'll move on to the next signature there. And then we can print out the name of it, which is going to be the file type. Okay, so let's try this now. Hashmap new. Help. Unexpected value found struct use : Oh, it's not dot new, I guess it's : new. Since it's a static. New is a static function. Now where is it? Hashmap. There you are. Okay, now we're getting some better help here. Oh, make signatures mutable. Okay. Now let's try recompiling. Beautiful. Beautiful output. Nothing. So we built it. We can also say cargo run, and I think I might have a JPEG somewhere. Yeah, there we go. I've got a picture there. Oh, well, it says okay. That's not what I was looking for exactly. Okay. That's nice to know, though. Oh, that's probably this one here. Otherwise, we can say else. In this case, we'll go ahead and print out a message to say no match, but we don't generally in the future want to print out misses. But just to kind of confirm our logic is doing what we think it is. Yeah, signature not found, but it is a PNG, so it should find them. So let me try something just to make sure. So let's go check out the picture. And let's open that up here. We'll say reopen with oh shoot, I forget how do I How do you specify the open with encoding? I forget here. Shoot, I forget. Okay, Sublime, open PNG as hex. There's a trick to this. Oh, I think they basically just said, just change it to a .bin, and then it doesn't know what to do. Yeah, okay, there we go. Then it turns off the internal image viewer. So let me make sure, does this PNG actually match what they told us it would? Oh, no, it's the wrong one then, because that was actually a JPEG signature. So that was like a JPEG alternative 2 or whatever. So that's fine. Let's actually just duplicate this. And we do want to make it work with multiple ones anyway, so let's add a PNG one in there. And let's do like that. I wonder if I could put that whole string into the calculator here. No. Okay, let's try this then. So it's going to be 137. Oh, wait a second. Yeah, 50 there is going to be decimal 80. 4E is 78. 47. 71. Okay, D is 13, right? Or is it 14? F is 15, yeah. 13? Jeez, I need to just make sure, yeah, 13. A is 10. 1A is 10 plus 16 is 26. And another 10. What? Why isn't it like that? Expected... Oh no, you can't even mix the types? I guess what I need is a vector then, huh? Can I create a vector of U8s? Like that? Hold on a second. Rust vector of bytes, characters. Vec new. Oh, right. Vec new, but I do want to specify the type. Is that not how I do it? Let's see, can I... Here we go. The vec macro is provided to make initialization more convenient. Thank you. Okay, so we do what? Vec? Then we pass it the list. Okay, awesome. That's very helpful. And that's pretty much exactly what I was looking for. So now it shouldn't complain because now they're both of type vector. And that's the PNG. So now let's see if the PNG is detected. Okay, hold on. I need to fix a missing parentheses. Okay, so signature not found for PNG. Let me make sure I didn't mess up these values. Calculator. Alright, let's double check. 89, 137, 50, 80. 4E, 78. 47 is 71. 0D is 13. 0A is 10. 1A is 26. And 0A is 10. So what do we have in our file? 89, 50, 4E, 47, 0D, 0A, 1A, 0A. Okay, so those are accurate and those do indeed match. So why does it not find? Let's figure out here. So why don't we actually print we'll actually print both of the values to see how they're coming out. And so that's actually going to be the byte that we're checking from each one. Okay, so now we should get some more debug information. Oh, okay. Oh, it worked that time. It says signature found. Hold on. Okay, I don't... Maybe I, hold on a second. Cargo run. Signature not found. Signature found. Signature not found. Not found. Signature found. What is going on? Look at that. It's going back and forth on whether it found it or not. It found it sometimes and it doesn't the other. What is going on there? It's not like... Is it creating threads that I have to wait for or something? Thread? No. That's really weird. Is it not? Does it seem weird to you guys? That I can run it against the same PNG and sometimes it finds it and sometimes it doesn't. So let me go back here and we'll say print line checking for, and we'll print out the name that we're actually checking for. Some more debug information. Checking for signature of file type. Okay. Checking for PNG. Oh. Oh, I forgot. We need to seek back to 0. It was only working when it happened first. Okay, because we're only reading... Wait a second. Well, we only read the buffer once. We only need to read the buffer once. But wait, where are we? Are we unwrapping the data? Where are we pulling the data out? Because that's a result. Oh, that's right. The data is the one telling us how many bytes it read. And the buffer should be filled once. And we shouldn't ever have to change it. We should be able to read it just once. Hold on a second. For each one we need to do this. We need to set like this, match to true. There we go. So for each file type we need to reset our match. Okay, let me try this again. Signature found PNG. Yeah, now it's way more consistent. Even though it's only printing out some of them? Oh, it's only printing some of them out because it's only printing out the ones that match. Okay, so now it'll print out all of them. Now we can confirm, like... Okay, hold on. So what we'll do here is say, file byte is going to be that one. And we'll do hex. We'll do upper hex. And then same thing with this one. We'll do, can we do a tab? Yeah, perfect. We'll do a tab here too. Tab, the tab to the signature byte. And then a tab. Okay. Cool. So now we can see, okay, checking for a PNG, and we can see each byte as it goes through and checks for it. Match, boom, signature found. And then here we can say, checking for JPEG, boom. So what we can do, what we could do, I'm not going to do it now, but like, here we'll say to do add dash dash debug or verbose to toggle this output. So that way we could say, okay, if we want the real verbose one, then we could see like, oh, you know what? It's one of those ones that was only off by 1 or something, and or we could just say, give us the quiet one and only output what we need. Okay, so let's see. I guess we could add maybe one more JPEG signature. Just to make it a little more complete. And you know what we could do? Well, I was thinking, because this one has, like, optional variables, maybe we could put, like, a -1 in there for those. So then we could say something like, if it's -1, then just skip, right? So like, if they match or the signature bytes is -1, then we're just gonna skip it. Or I guess we could say, if these bytes don't match and the signature, sorry, it's the signature bytes of index I does not equal -1. So it's saying, okay, if they don't match and you don't get the special symbol telling you that it can be anything, then it doesn't match. So let's try that and see if it barfs on us or if it works. Okay. So we'll call that one JPEG 3. There we go. And let's go ahead and convert those real quick, just so we have them in there, and then I'm going to call it pretty much done. And then, what do we want to do? I want my calculator again. Calculator. Well, you know what? I'm not going to bore you guys with that right now. Well, you know what? I really did want to see whether that -1 thing works or if it breaks everything. So these first 3 okay, and then we've got E0, 224. Actually, yeah, these are long. I'm not going to bother doing that right now. I will. I'll do this. I'll leave them blank and then come back to them. And we can still leave this logic here. It's not going to hurt anything. I'm assuming that... No, see here it says their vector of unsigned 8. So we can't have a -1 with an unsigned value. Now, maybe I can be explicit here. I'm going to say, and then this I want to be an int. Now, wait a second. Oh, it's a vector. That's right, it's a vector. So it's going to be a vector of int 32s. Shoot, what's the int type? Rust int type. What? Data types. Integer types. Oh, it's just I. So I guess we can say I32. Hold on, it doesn't like my... It's because I have too many. Hold on. Hashmap new Rust. Something's weird. It doesn't like my syntax, or I'm doing something wrong. How do I do it with explicit types? Address is... So is that how I do it? Is that actually... Do I do at stir like that? What is it complaining about here? Add bin up. I'm really confused about why it's... what it's actually complaining about here. Yeah, there's an example there. Oh, is it... does it need to also be like an address? Oh, do I need to do it over here? Do I need to say over here is where I define the type? And then over here I just call new. There we go. That's what I was doing wrong. I'm supposed to define the type over here with the variable name, not over here when I call new. That was my problem. And then here I want to make it... Interesting. Why does it assume... hold on a second. It's here. It's creating the vectors of type U8, and I want it to be like an I32. So let me see what this vector macro does, because I'd rather do it myself. Okay, can I... how do I do... Oops. How do I do it without... Here we go. I guess it would be the same way. So I'd have to create it first. No, I should just be able to say new. can I do it there like that? No, I think that breaks the macro. Maybe I can do it there. Hold on, let me try this out. Vec macro specified type Rust. Okay, if I want to call new, I want to call new, but I want to pass it the values. It doesn't seem to just kind of, doesn't know what to do with this. Yeah, new doesn't take any parameters. So, can I append a whole list at once? What's going on here? Starting to, let's see. A vector of I32s. No, wait. I'm gonna have to do it like, I don't know how to do it without defining it like this. And saying like, let signature of type vec equal vec new, and then like appending it to it. Like that. Like, that works. But integer. Yeah, so like I'm trying to understand these types here. Because I don't want to have to create a new one each time like that. But if I did want to and just return a new one, like, okay, how about like that? But see, like when you specify the type like that, it just kind of throws up at you. Dynamic new vector Rust. I know there's the macro, but the macro's not really. So let's see, there's new. Construct a new empty one. Will not allocate until elements are pushed to it. It's too bad there's no just like maybe a excuse me there. Maybe there's a way to convert array to vector Rust. Maybe that's what I need to look into. To vec? Okay, so maybe I can do that. Because before I was just passing the numbers. Oh wait, I was doing vec, right? But maybe I can do to vec like that. Why won't it just... Why does it insist on treating these as bytes instead of as integers. Like, do I have to do that for each one? What do I have to do to convince this that they should be I32s? Oh, okay, hold on. It's actually getting closer. Expected the address found vector. Okay. How do you get? So that actually seemed to finally convince it. Dot vec as, can I do like that as a vec? Oh, no way, did that finally work? Okay, because then I can actually keep doing it like this, and then I can say to vector as this kind of vector specifically. I thought it was just working a second ago. Okay, yeah, there we go. Okay, let's try running it again now. Unexpected U8 found I32. Okay, that's totally fine. And the only reason I'm even using them even temporarily as these I32s is so that we can put the -1 value in there. Because if they're just unsigned ones, we can't use them. So we know the byte is going to be a byte, so we can, I think, convert it and be like, hey, let's just. I know you're an unsigned byte, but we're still going to treat you like a signed 32-bit byte. And good, it's working still. So. Moral of the story there. To vector as vector I32 from a list or an array. Now, why not? Let's just go ahead and knock these out. Come on, calculator. While I'm doing this, maybe you guys can... What do you guys think about Rust? Have you guys ever used it? Any thoughts? Any thoughts just from watching me mess around with it? 216. Okay, FF is 255. E0, 224. 0, 0, 0, 1, 0 is 16. 4A is going to be, what's 64 plus 10? That's 74. 4, 6 is going to be 4 less than that, so it'll be 70. 4, 9 will be 3 higher than that, so it'll be 73. 4, 6 again. 0, 1. Awesome. Who needs a calculator? 255. D8 is going to be 216. FF 255. E1. E1 is going to be 225. And then these are actually going to be -1s, and those are the special values. And then 45 is going to be 64 plus 5, 69. 78, what's 78? 78 hex and decimal is 120. 69 is 105. 66, I guess, would be 102. 00. Okay, so now we've got a handful of signatures in there. And I'm going to want to change how these are done. Actually, you know what? because the first one specified the type, these other ones seem to be falling in line now. Because I specified the very first one, the other ones are like, okay, now we understand what you meant to be used here. So it looks like I can still use the vector macro as long as the first one, so that the implicitness gets set. Cool, so let's try some JPEGs. And I'm actually gonna comment that out because it's a little too verbose. So do we have any JPEGs? Let's go find a JPEG. Free JPEGs. You guys know where I can find any free JPEGs? There we go. Oh, that doesn't look like a JPEG. How about this? Save image. Is it a JPEG? Are you a JPEG? Dot. Are you a JPEG? On my desktop. Alright, let's try this out. Cargo run on desktop. Are you a JPEG? Signature found! JPEG 2. Ding 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 ding. Okay, now again, let's hide the not founds. And let's also get rid of this checking for. So now, let's fix these warnings too while we're here. Consider using _sig. Warning, unused variables. Oh, which one am I not using? That one? Oh, right. No problem. Let's just delete it. And data? Data's not being used either. Hold on, where's data? Yeah, I guess we can just discard it since we're not using it. Oh, it has a result that must be... Wait, there we go. Now we're all good. No more warnings, so we are nice and Rust compliant. Now look at that. It found it. It was a JPEG indeed, after all. And then let's try our PNG again. Awesome, signature found. What about the one that's just yeah, this weird copy.bin? Oh, signature found, PNG. So there's a way for you to check file signatures as long as they support signatures that are not only at the very beginning of a file. So it's a little limited right now and fairly stupid, as it'll only check the signatures that happen at the very beginning of a file. Otherwise, I'm happy with this. This is useful. So if we needed to look for some specific signatures, we could do it here. Otherwise, what I would do is like create an array of all the functions and then create a specific function for each one to check. And then each function can control, each signature can be a function that's checked uniquely for its own special logic. But that's going to do for now. So I'm going to add this. And I'm going to say adding the find file signatures application. Awesome. So these are all some very basic tools, but they're useful. They actually have practical use cases that you can use and apply if you're doing reverse engineering, CTFs, you're just trying to like figure out what's going on with the file. So where are we at right now? An hour and a half? Let's see. Briefly, I'm going to check out, let's skip ahead, I want to see, what about the Exif data? Exif data Rust crate. We're looking for, yep, here we go. A Rust crate that supports Exif. That way we could do something like scrape, like if we find the image, like we just use this one that says looking for file signatures, and we're able to detect PNGs and JPEGs now. Now, what if we took it a step further and said, okay, if it's a PNG or a JPEG, see if there's any Exif information. Exif information, if you don't know, is the metadata that's usually on files and images and video and things. So it contains things, yeah, like geolocation, what kind of camera the picture was taken on, the date, the shutter speed, all kinds of information. And if it's like it can even have information like your username and things like that. So I just wanted to see if there was a library out there, and it looks like there's actually a couple. So there's this one, this one. Okay, so it looks like a handful of them are actually just, let me make this bigger. Some of these are just bindings to live Exif, which is the C library, which is fine. Here we go, Exif parsing library written purely in Rust. This library can parse TIFF and JPEG images. Okay. I'm not going to implement this one right now, but it looks like check out third-party crates. And then steganography, so the idea with the steganography is the easiest way to do it is to take like a zip file. So watch, we'll zip that into hold on. How do I zip? Hold on. One second. Okay, I don't know why I'm having some kind of brain fart there, but like, let's say compress into a zip. We'll call it test.zip. Okay, and then we'll take. We had a JPEG on the desktop, right? Yeah, so let's actually change that to a JPEG. So what you can do is something like this. You can cat the JPEG, RU a JPEG, and the test.zip into a new file. We're going to call it just an image. Okay, so now we should have... Here we go. So here we see we have a JPEG file. We've got our JPEG file. All, you know, it's all good. It is the same image, same quality and everything. But if we look at the details of the images, you can see this one here is 32, sorry, it's kind of hard to see. This one is 32.4K. This one is 32.8K. So where's that extra 4K? It's because this zip file is actually embedded in there. And so you can see that one is about 400 bytes, which is 0.4 of a K. So check this out. You can... It still loads up just like an image, right? But if you say open with another application and you open it up like, let's say, with Archive Manager. Oh, it's not going to do it, so, but you can do like this. You can say unzip just an image. And you pop it out. It says, warning, there's a whole bunch of extra bytes at the beginning. Do you want to do it anyway? Yes. And basically, see, it just inflated hello.js, and now we actually got the file out of it. So what happens is what happens is because the JPEG has the file signature at the very beginning, and the zip has the signature at the very end. So when you go and say unzip, it's jumping to the end of the file and it's saying, okay, how many bytes do I need to go find and unzip from the end? And that's why it even warned me. It was like, hey, you know, you've got a whole 32.3K bytes at the beginning of junk. You know, we can still process it because we're going to ignore it, but I'm letting you know there's a bunch of extra data. And that's the JPEG. So when you open any kind of JPEG viewer, it's going to do the same thing. It's going to look at the signature at the front. It's going to go, okay, this JPEG is 32K. So I'm going to read the next 32k bytes, and if there's a bunch of stuff at the end, I don't care, I'm going to ignore it. So both of the tools treat it just fine. Like, you can treat it like a JPEG or a zip. And if I rename it to a zip, then when I open it with the Archive Manager, oh, this one actually has a problem with it. As you can see on the command line, it worked okay. It worked just fine. I can even do it again. But that's interesting that this one broke still. Anyway, that GUI one doesn't play well with it, but you can still unzip it. So the idea is you're hiding a zip file. It works with RAR files as well. So you can basically have an image that looks like it's just an image, but actually have a hidden zip file in there. And that's where finding the file signatures would come in handy, because you can go, oh look, that one is called a .zip, but there's actually an image in there, or vice versa. Okay, so basically all you're doing is, concatenating the bytes together there. So we basically say write the bytes of the JPEG, and then right after it, the bytes for the zip. Now, another form of steganography that's much harder to detect, is doing it inside of video, audio, or doing it within the data of the image. So for every pixel in the image, there's generally the R, the G, and the B value. And what you can do is you can take the low bits, just a couple bits of the low bits that make very little difference in the color, and you can use like 2 bits out of each pixel, and you can splice together a file that way. So you have to have much more specialized software to do that, but we can make one of those potentially too. So Spudley says, aren't there programs that will sprinkle the bits throughout the image? Yeah, exactly. So that's exactly what I was talking about. So I know, for example, if you go pull up the Go image library, they have a very nice format where you can say, like, you just load up an image. Examples. Yeah, decode a JPEG image. So basically, once you decode an image, you can access each element. This is not a good example. Neither is that one. Anyway, it becomes pretty easy once you have the right package to open the image data, because otherwise you have to like decode the header from the JPEG image from the body. But if you've got like a JPEG parsing library, it makes it much easier to just easily cut out the last 2 bits out of every byte. And so the big trick for these, where we say let's go through a directory or a whole disk and look for large files or recently changed files, the big trick there is walking the directory. And so there's probably Rust, walk a directory. Oh, yeah, they do. So they do have a built-in unstable. The precise semantics and defaults for a recursive walk may change, and this may end up accounting for files such as symlinks differently. Okay, so they don't particularly recommend you relying on it, but walkdir, yeah, so you basically get a result of a walkdir type, a struct rather. Okay, so they have a whole struct called a walkdir, and that's, you can iterate through it, so you can say, okay, go through each one, and then you can just say go through each one and then do a comparison and then sort the results at the end. So that's the idea behind those. The Exif is just going to be using a third-party package. Steganography is going to be, one, copying the raw 2 files back to back, and then maybe exploring an image library to hack away at the low bits. And then modifying the timestamp and access times should be Should be relatively straightforward. Spudley says, of course it's all still very detectable. Would probably want to encrypt whatever you're putting in there. Yeah, you're right. It's not encrypted. So if somebody had the right tools and they wanted to go through and say, okay, try pulling one low bit and putting it together, a piece of data. Okay, how about pulling 2 bits, piecing together data? How about pulling 3 bits of the low bits and piecing it together? Someone could potentially eventually go through and find your data. If you're putting your bits in just the low bits, then none of the file signatures should get triggered. But you're right, you absolutely would want to encrypt it, but the problem there is if you're encrypting it and you're sprinkling into the low bits, you need a lot of pixels in an image. So you need a really big image with lots of pixels, you know? So that becomes, you need like a massive, massive image. But anyway, I think that's all I'm going to cover for tonight. So, yeah, last night we did getting the file metadata and dumping hex values. Tonight we looked at how to look for ASCII characters in binary files and how to have a collection of file signatures and look through them. So our cookbook for file forensics in Rust is getting better. Basic file forensics again, nothing too fancy. So before I log off, I'm going to do my plugs real quick. So go ahead and subscribe if you're not already subscribed. I've been doing nightly live streams and would love for you guys to come out and chat some more. I really love the chat. It makes this a lot of fun and I learn a lot from you all too. So I hope you guys enjoy it too. If you want any of the code, go to github.com/devdungeon. And tonight the code that we've been working on has gone into the cookbook repository under the Rust folder in the cookbook. And so there's find ASCII and file, dump hex. Wait, did I forget to push one? Yeah, let me push. There we go. Okay, so we should also have, there we go, find file signatures. So there's our example for that one. Okay, cool. So I don't know if I'm going to do these tomorrow, but I'll probably do these in a very soon upcoming stream. If not tomorrow, maybe the day after that. I think tomorrow I might go back and do the bug bounty plugin, the Firefox browser extension that we've been working on to build a bug bounty helper tool. I'll probably work on that tomorrow. So also, if you're not on the Discord server to come hang out and chat, go to devdungeon.com, and in the right sidebar there is a Join Me on Discord button. Click that, come hang out and chat. Buy a few copies of my book, Security with Go. You can buy physical copies or ebook copies. And check out devdungeon.com for a bunch of other tutorials and blogs and things. So, again, I really appreciate y'all coming out. I will see you guys tomorrow.